Our last big pair of topics in this class would be functions and relations. And these are talked about in detail. We look at the properties of functions and relations in Chapter 7 and Chapter 8. Functions and relations are closely related to each other. And for both of these, we have our definition going back to the beginning of the text in section 1.3. First of all, a relation that goes from A to B, a relation R from A to B, where A and B are sets, is a subset of A cross B. Remember, A cross B is a set of ordered pairs where the first element is from A and the second element is from B. In this situation, we call A, the set A, the domain, and the set B, the codomain. And we can have shorthand notation here where we will say X is going to RY, R being the relation that we have here. X is going to RY means, or we can say if and only if, the ordered pair XY is an element of R. Now, let's take a look at an example of this. Suppose I have as my domain A being the set with A, B, and C, and my codomain a set being 1, 2, 3. So you notice these things don't all just have to be numbers sitting out there. They could be anything. Well, if I look at A cross B, what I get is a group of ordered pairs. We have A paired with 1, A paired with 2, A paired with 3, B paired with 1, B paired with 2, B paired with 3, C paired with 1, C paired with 2, C paired with 3. That is all of the things in A cross B. Now, a relation in here would be taking any subset of that. So if I took the subset of, say, these three, that would be a relation. But if I took a subset of all of the ones, say, in here that are in red, that is also a relation. So we can define relations and show them as sets of ordered pairs. Another way that we can show a relation is by making an arrow diagram, where we would show set A and set B, and we can show the relation by saying that, say, on this first one, the one that I drew coming down here, A is paired with 1, B is paired with 2, C is paired with 3. We can say 1 is the image of A, 2 is the image of B, 3 is the image of C. The second one I did had A paired with 1, B is paired with 1 and 2, and C is paired with 1, 2, and 3. This is also a relation. So we have several ways we can show these. We can show them as ordered pairs. We can show them as arrow diagrams. Here we could say that if the relation here is called R that goes from A to B, A is going to R1, B is going to R2, C is going to R3. Over here, A is going to R1, B is going to R1, and B is also going to R2. And C is going to R1, C is going to R2, and C is also going to R3. So we have all of those relations. Here's another example. I have a domain A with 1, 2, and 3, and a codomain B with 0, 1, and 2. And this time, I've written a rule here that says the ordered pairs XY are elements of the relation if and only if the X value is less than or equal to the Y value. Well, if we go through these elements in here, the 1 is not less than or equal to the 0, but the 1 is less than or equal to the 1. So the ordered pair 1, 1 would be in the relation. 1 is less than 2, so the ordered pair 1, 2 is in the relation. 2 is not less than or equal to 0. It is not less than or equal to 1. But 2 is less than or equal to 2. So 2, 2 is in the relation. 3 is not less than or equal to any of these, so there are no pairings with the 3. So what we have here is our relation defined as a set of ordered pairs. If I wanted to show this relation with an arrow diagram, I could put 1, 2, 3 here in the domain, and in the codomain put 0, 1, and 2, and what I have is that the 1 is paired with the 1 is paired with the 2, those are arrows, and the 2 is paired with the 2. And this is an arrow diagram showing the same relation. Let's do one of the ones from your text. It's maybe just a little bit more involved. This is number 2 in section 1-3. Here we have two sets, C and D, that are comprised of -3, -2, -1, 1, 2, and 3. They're going to serve as both the codomain and the domain. And we're making a relation S that goes from C to D. And we're going to say that the ordered pair XY is going to be an element of that cross product. And we're going to say that that ordered pair is an element of the relation if and only if 1 over x minus 1 over y is an integer. So now we're asking, does 2s2? Okay, it's an interesting way to talk about it, but that's how we usually describe this. Well, if 2 is going to s2, then 1 over 2 minus 1 over 2 is going to be an integer, and 1/2 minus 1/2 is 0, so that is an integer. So yes, 2 does s2. Does -1 s -1? Is 1 over -1 minus 1 over -1 an integer? Well, yes, that is also something that's in here, because this is going to give us an integer. Now, different notation, but the same idea. Is the ordered pair 3, 3 an element of the relation S? Well, same question. This is asking, is 1/3 minus 1/3 going to be an integer? And the answer is yes. Now here it's asking, how about 3 and -3? Well, is 3 minus 1 over a -3? Now that one's kind of interesting. Here we're going to add those two together and get a 0. So this is also something in there. Well, what ordered pairs are going to be in here? We can see that 2 and 2, 2 and -2, 1 and -1, 1 and 1, 3 and 3, and -3 and 3 are the ordered pairs that are going to be in here. Is there anything else? Let's be careful. I was a little too fast with this. These two will work out to being an integer. These work out to being an integer. How about 3 and 3? If 3 and 3 will work because it's 1/3 minus 1/3. But if I do I'm sorry, if it's 3 and 3, it'd be 1/3 minus 1/3. But if I do 3 and a -3, 1/3 plus, minus a -1/3 is the same as adding these two. That's going to be 2/3, so it's not in there. So if they are of different signs, that won't work. We have to take that one out. This one is not an integer. That one was a little tricky. Sometimes the rules for these can be a little tricky. We don't have to examine every single one of them. The domain here, that's a pretty straightforward question. The domain here is the set C. The codomain here is the set D. They happen to be the same set. If we wanted to do an arrow diagram of this, you could see that, say, 1 is going to relate to 1. 1 is going to relate to a negative 1. These also relate. 2 is going to relate to negative 2. 2 is going to relate to 2. 2 is going to relate to negative 2. 2 is going to relate here. We saw that 3 is going to relate to 3. How about not negative? Okay, negative 3. 3 is not going to relate to negative 3, but negative 3 is going to relate to this one. So we could do an arrow diagram. There's several more problems like this in your text that are on page 21. There are problems 1, 3, 5, and 7. Why don't you try looking at those and do those before we move on to looking at functions?